Well, having victory over voltage drops requires you've got a good battery to do voltage drop testing, amp testing, and so forth. It wouldn't be a bad idea to check the charging system while you're at it. Believe it or not, somewhere underneath all this plastic, computers and things, there's a 12-volt battery. So let's see if we can find it here. And we'll show you another piece of equipment we've got on this vehicle because it's had some battery rundown history. There's a big ECM, PCM, and we're going to go ahead and pop that out. It's actually pretty service friendly. 2011 Equinox here. Lay the ECM, PCM aside. Well, there's our OE battery and positive and negative cable. But on the negative cable, that's not OE. This is a tool from Midtronics. By the way, we're keeping this battery up with a Midtronics PCS 550. It's a 55 amp battery maintainer. It'll charge a battery to a point. It's not truly the battery charger you want to put on the dead battery. But if you want to maintain a battery while you're doing testing, especially while you're flashing, because this is a quiet, clean charger required when you're doing module reflashing, J2534, factory programming, whatever you're doing. So I want to keep this battery up while I'm doing my testing, so I've got my little battery junction point here on the Intelligent Bus Electrical Center and also over here on ground. But on the negative cable of the battery, there's an aftermarket accessory actually a tool, diagnostic tool by Midtronics, and that is the IDR. And that is the device that we can use to record not only battery drain, but up to 3 or 4 other channels of information on a long-term scale. We're talking 3,000 hours of recording time. This is a data recorder. And as the engine runs, as you shut it off over the course of several days to accumulate that 3,000 hours, this thing takes samples. And when it sees an issue, it takes samples much more quickly, so you have better, higher resolution. So we can pop out a little memory card of this and play it back. And we'll be doing that in a future video production on parasitic current draw. One of the most well-read articles on the AVI Scope It Out website for tech articles has been parasitic current drains. And so my experience as an auto electric guy from way back, as well as students and techs, people that tell me, you know, hey, I have all kinds of issues with battery drains. So basically you disconnect the negative battery cable, kind of stuffed in there out of sight, from the post, and then connect one side of the Midtronics IDR to the battery cable going into the vehicle, and then the other side, this cable from the IDR goes to the post. So all the current flows through the negative side of the battery cable in series through the Midtronics IDR, so it can monitor battery parasitic current drain. And not only that, but also charging current and the current from the starter motor for hours and hours and hours. 3,000 hours, that's a long road test. So we're just going to leave this tool in. It's doing the job. We're going to have it in there a few more days recording data for another issue, another project, a parasitic current draw, and then we'll pull it out eventually. But for the time being, we're going to leave it alone because it's basically just a box in series with the battery cable. Explain that a little bit and talk about this Fluke 365 multimeter we've been using in this program. This is the handiest little tool. We can go ahead and check battery voltage. Now before we do that, let's go ahead and take off the Midtronics battery maintainer. We'll flip it off. Take our leads off because we don't want to be measuring the battery voltage if it's got a little helper on it. Now just for grins, we should see 12. Handy little magnet to hang it up there. And we'll turn it to volts. Put our backlight on, and we should be seeing about 12.6, 12.8 of a fully charged battery. Actually 13, got the surface charge on it. We can remove that surface charge pretty quick. Turn the headlights on for a sec. About 30 seconds, actually. 30 seconds. Let that surface charge come off. That should do it pretty close. And back off again. So there's a surface charge cut back. There's a 12.8 fully charged battery. Let's go to start the vehicle now. Now, what we want to do is possibly see what the voltage drop is as we start the vehicle on the battery itself, what battery supply voltage is, as well as what the current draw is in the starter. That's pretty easy because the clamp comes right off. You can leave it on or you can take it off, unwind the cord, make it nice and convenient, and we'll just clamp it around that negative battery cable and have our assistant crank the engine. I'll hold that steady so you can get a close-up of that. .2 volts is what it got down to. We take the hold button off. Now we're charging at 14.6. That's good charging voltage. Now let's turn it to amps, and we're not getting another tool out. We're just using the same tool with the amp clamp already in place, and we're about 9 amps of DC going into that battery. Go ahead and shut it off. Now we'll go ahead and crank it and watch the current draw. For a moment I couldn't get the hold fast enough, but for a moment we were just at the threshold of this meter. This meter is not super accurate below 1 amp, so it's not really the ultimate tool for those splitting hairs parasitic current draws, but it will go up to 200 amps. So for the average amp clamp job, this does a wonderful job, and I like the fact that little amp clamp just stores right in the tip of this thing. I don't have to get another amp clamp out. Let's go see what else we can do with this Fluke 365.